Okay, welcome again to Science and Democracy, Vetenskap och Demokrati. And this week, our discussions are about the role of values in science. So when one thinks about values, one thinks about questions about what matters to people, about what is morally correct, morally appropriate. One thinks about questions about who's accountable, what is right, what is wrong, what is just, what is unjust, and such questions. That's the sort of things that come to mind when one thinks about values. There's some other terms that you see here on the left people think about when they think about values. By contrast, when one thinks about science, one often has particular theories in mind, things about the nature of the world, what really is the case, people know, and so on. And there's a tendency to think that those things are different from these questions of values. So the question is then, what role do values have in science? That's what we're going to talk about today. The readings were about that. So there's sort of two questions here that is important to distinguish. And that's the first point I want to make in this lecture, distinguish between these two questions. On the one hand, there's a question about what role do values about what's morally right, for example, in fact play in science. Question about what matters to people, so on. Question about verdía, values. Here, the question is about, it's a descriptive question, or you might think a scientific question. Do scientists, for example, think about questions of ethics, of value when they do science? Do they ask normative questions? Do they think of what they do as a question of their values? So these are questions about what role do various values play in science? Do scientists appeal to values? Do they think in terms of values? When do they think in terms of values? That's a scientific question. Indeed, I have a colleague here at the Center for Philosophy and the Sciences who is, for example, interested in that question. He's looking at how and when do scientists ask value questions when they do science. So that is a question he investigates with his research. He's looking particular research about personalized medicine, where we looked at that. Do the scientists think that this is a matter of value, and so on and so forth. But then there's a different question, the second question. That's a question about what role should values play in science. That's not itself directly a scientific question. It's more a philosophical question, and that is itself clearly a question of value. It's a question about what should be the case in science, not about the case, not about what actually happens. So I might, for example, and those are two distinct questions. So there is a gap, as philosophers sometimes say, between an is, what is the case, and an ought, what ought to be the case. There's a gap between facts and values. So suppose your father lied to you about, say, whether you had a job as you were growing up. Suppose you didn't have a job and he just pretended to have a job, and in fact he was hiding the whole day in some other place and he was gambling and making money that way. Now, the fact that your father lied in that way does not entail that he should have lied or that it was morally okay or right or appropriate for him to lie. Similarly here, the fact that we find that values play a role in science doesn't show that those values should play a role in science. Or if they, so play a role, it does not show that it's appropriate that they play a role in science. They might be wrong, just like the fact that your father lied to you might be something that fact happened, but that was wrong for him to have to do. But they're also not necessarily completely disconnected question. Many philosophers think that if something is impossible, then it doesn't really make sense to ask, should anyone do it? I mean, if you think, should I now, start to fly? If you think that's a stupid question, I cannot fly, and so then it doesn't make sense to ask whether I should do it. Now here that one might think, well, suppose that values in fact play a role in science, and suppose further that it's impossible that there exists any science without values, then one might say that it doesn't make any sense to say that then values should not play any role in science. We'll get back to this question, but the connections in those two questions. But it's important for us to keep in mind that the question whether values do in fact play a role in science, that's a descriptive question of what is the case, whereas the question about what role values should play in science is a philosophical and normative question that is not directly answered by the question what role they in fact play. Okay, so now we'll talk about the so-called value-free ideal of science. This is something that answers to the normative question, the question of the ideal, how science should be. So those who accept the value-free ideal about science, so that science should be value-free, ideally, they accept that values in fact influence scientific research. For example, they influence which scientific projects get funded and which scientific questions get asked. And indeed, they also accept that that's okay. So they also say that it's okay. It is morally acceptable. It is acceptable. There's nothing bad about that. Values influence scientific research in those ways. Just think about the question which research gets funded. Obviously, there's now a lot of money flowing into doing research on vaccines having to do with this new coronavirus. There's a lot of research in epidemiology that gets funded. These questions get asked. It has something to do with solving a practical, broadly speaking, problem that people would die otherwise. This is a question of value, that those questions get asked right now and that those projects get funded right now. But that's really only about what one might call the direction of attention in science, what scientists pay attention to, which projects pay attention to, which questions do they pay attention to, which questions do they ask. It's not about the question of which theories in science are scientifically acceptable or good scientific theories. So those who defend the value-free ideal, they think that those two things should be clearly distinguished. So those who defend the value-free ideal, they reject a role for values in scientific justification when it comes to which scientific theories are acceptable. And I want to illustrate this with this example from these days. This is actually a research paper on the left that I encountered just today, this morning. Now, here's a question many people are interested in these days is, are children, do they get the coronavirus as often as adults? Many people are interested in that because the question of whether the schools should be open or closed depends on that. And different countries have made different decisions on this. Now, here's a kind of inference someone might make. And I'm sure there are many people who make that kind of inference. They think, well, it's valuable to me that my child goes to school because I want to go to work and it's very stressful to be at home with 3 children, taking care of them. And you conclude from that, now the science shows that children almost never infected with the coronavirus. Now, that would be a horrible, bad inference. They call it this problematic inference. It's clearly problematic to conclude from the fact that something is valuable to me, that it's true. And those who defend the value-free ideal, they're often driven by the idea that this inference is very problematic. You can't conclude from the fact that it's valuable to me that it's true. And so you can't use these values to guide science. Not just valuable to you, you might think it would be better if science, if children were less susceptible to the virus than adults. That still is not an indication that the theory that they are less susceptible to the virus is true. Now, I already want to note here that the value-free ideal we'll see rejects only the involvement of certain kinds of values in scientific justification. We'll get back to it in just a minute. So one way this is often put, the value-free ideal, is to distinguish between 2 logics. So that's a way this has been put in the 40s and 50s. The logic of discovery, the logic of justification. The logic of discovery is about why something gets discovered and when. The logic of justification is about when is a scientific result justified or acceptable. So values, according to the values, those who defend the value-free ideal, think they clearly play a role in the logic of discovery. So which questions are you asked to determine why something gets discovered at a certain moment? So for example, that right now we're finding out about the vaccines. That is a result of asking these questions right now. And we ask the question because we think it's extremely important, extremely valuable to have this information right now. On the other hand, is the logic of justification. That's about, is the theory, a particular theory, scientific theory, justified or acceptable? And their values about what would be good or what would be morally right shouldn't play any role, according to those who defend the value-free ideal. So it shouldn't play a role that it's good for me or good for society that children are less susceptible to the coronavirus, for society, for scientists to then accept that they are less susceptible to the virus. So since there's a distinction here made between the way something is in fact discovered and what justifies the theory, this is in a sense an ideal. It's ideal science where that's sort of just the way we just look at theories and evidence for them. We don't think about how in fact it's discovered. In that ideal science will be completely free of any values. Okay, now, is that really defensible? Already, as it was in the reading by Douglas in our texts, already in the 40s and 50s, people pointed out that there is a gap, and actually before that, a gap between evidence and theory. So empirical research is engaging in what philosophers call inductive reasoning. So you have some data, and from that, you conclude to some theory. And we've talked about this already when I showed these dots and said, well, there are many ways from these dots, in many ways to draw a line through them, have some theory about it. And so in that sense, many theories are compatible with these data. And that's true for any kind of inductive reasoning. The famous inductive reasoning, some of you might have heard, is from the fact that the sun has risen every day in the last, every day ever since I can imagine. That leaves open some possibility that maybe the sun is not going to rise tomorrow because the earth is blowing up or something like that. So the data leave always open several theories in empirical science. Now, as you gather more data, some of these theories are going to be less likely to be true. So I indicate this with the arrow getting thicker and thicker for theory one. As you accumulate more and more data, that will give more and more weight to a particular theory. And we talked about this last week when we talked about Strevens. I think that that's sort of why science is so successful. It accumulates over time a lot of data that then provide more and more and more support for particular theories. But even though that's true, there's never the case where it's impossible that some other theory is true. There could always be some other theory that would be true. So it's never a point where there's no gap. And that's what's called often the underdetermination of theory by evidence. That's in a sense what William James was pointing out when he suggested that we have to weigh between, are we willing to accept, do we want to accept only truth, or do we want to avoid falsehood? It's like, how certain do we need to be to accept the theory one? Is it at the middle stage? Is there more data? And again, more. And that is something that Popper was also thinking about, the problem of induction. We can never be sure. And is also what philosopher Quine is talking about. So there's always some gap between data and theory, always some. There's the data itself never determine any theory. That gap then, that's the thought that was already discussed in the 50s, needs to be filled somehow. We saw that also already with William James, when he saw that when the data is inconclusive, then it's okay to use your values to decide to believe one theory or another theory. So Rudner argued in the 50s that the gap is filled by, in part at least, ethical or moral considerations. So, and therefore value do play an essential role to determine which scientific theory is scientifically acceptable. So not just in the logic of discovery, but also in the logic of justification. So take then this example. So this is actually now about this paper. So whether the evidence for the theory that children have the coronavirus more often than adults, so do they have it more often than adults, or do they have it less often? If that's a theory, they have it more often. That's theory one. Is it good enough? Someone like Rudner would argue that that depends on how ethically important it is for us. Either to wrongly accept the theory, so we accept the theory that children have the coronavirus more often than adults, even though it's not true, so we have a false positive. That might be it might be very important to us not to make that kind of mistake, that we quickly accept the theory, even though it's false. Or it might be, on the other hand, very important to us not to make a false negative mistake. There we wrongly reject the theory, even though the theory is true. And he says, well, the only thing that can decide between those two things is, these are values, ethical, moral considerations. That's just the William James point that we have talked about earlier, that do we want to avoid falsehoods or do we want to accept truth? It's going to be values that's going to make that difference. Good. So, but now defenders, so this is against the Rudner point is against the value-free ideal. Defenders of the value-free ideal, though, have argued that James and Rudner point actually is compatible with the value-free ideal. Okay, so now I would like to tell you about that. So two philosophers have made the point in two different ways. Jeffrey, who wrote a lot about decision theory, game theory in the 50s and 60s, he thought that science, strictly speaking, should never accept any theory. So what does that mean? What he means with that is, strictly speaking, the only job of science is to assign probabilities to various theories. How likely is a theory true? So in scientific publications, you see often these graphs like this. So this is measuring the length of the tail of cats in Norway, and so like, do the black cats have longer tails than the white cats? Okay, and so now we might find that they have a little bit of a longer tail or something, but then what do we now have? Should we accept the theory that black cats have longer tails than white cats? Well, Jeffrey thinks science doesn't, strictly speaking, tell us about whether you should accept that theory. It tells us only that there's such and such a probability that they have a longer tail. So that's why in scientific publication, you have these so-called error bars that tell you that this is the probability, there's a certain range of values that are probable. In fact, there's a distribution, a probability distribution for the blue bars and the orange bars. And if these probability distributions overlap too much, then we can't really distinguish them. They overlap less, then it's easy to distinguish them. And the only thing that science, strictly speaking, according to Jeffrey, can tell you is that it's quite likely, say 0.8 likely, that black cats have longer tails than white cats. But it can't tell you that a theory is, strictly speaking, true. Exactly because he thinks that would require values, and values have nothing to do in science. Levy is making that point in a slightly different way. Is making the point that values have no role in science in a different way. He says, well, yeah, certain values, that's true, must play a role in science. That's that logical point about induction, that to accept the theory, you always, the data underdetermine the theory. But that doesn't show that any moral considerations need to play that role. It's epistemic or cognitive or scientific values that should play the role it plays. Do we have a simple theory here? Do we have a theory that's broadly accurate? Do we have one that does explain many different things? Is it a unified kind of theory? And we saw a lot of these scientific values when Philip Kitcher and Imre Lakatos described what it means to be successful science or successful research program, that it has theories of those kinds that have these signs of a good theory. And so those things we should use to jump from the data to the theory Levy things. And those things don't let any moral considerations in. So what's then the value-free ideal? It's says that only a very limited set of epistemic values are significant when a theory is scientifically acceptable or scientifically established. That's going to be the same for all scientists. That excludes moral, ethical, or political values. So either that, or the only thing that scientists should do is assign probabilities rather than accept theories. Okay, so this was my exposition of the value-free ideal. And in the next part of the lecture, we'll then look at possible arguments one might make against that value-free ideal.